This is the CCEA Factfile for A2 Chemistry. It's 5.6 Electrode Potentials, and these are the answers for the questions. So question 1, standard electrode potentials for two half cells are shown below. We've got Ce3 plus going to Ce solid, and we've got TH4 plus going to TH. The top one minus 2.3 and the bottom one minus 1.9. Which one of the following species is the most powerful reducing agent? For the most powerful reducing agent, that's the one that's most easily oxidized, and of course that means we look sort of the left-hand rule, so at the top we're looking for this species which is going to be oxidized, so of course the reaction will go to the left, and that is B, so it's C. Okay, question 2. The cell shown below was set up to investigate the reaction between an acidic solution of VO2 plus ions with acidified manganate 7 ions. You see here we've got platinum electrode, we've got the solution of VO2 plus on the left, the manganate ions on the right, and salt bridge in between, and so on. So the standard electrode potentials for the two systems are shown below. Now I've made a correction here because in the first one, the equation, we have the VO2 plus and hydrogen ions, and then VO2 plus again on the right, but of course that should be this, the VO2 plus there. So they're written with the vanadium at the top and the manganese at the bottom, because the vanadium one has a more negative electrode potential. So explain in which direction the electrons flow in the external circuit. Well, they flow from the negative to the positive electrode. And then you need to say for your other marks that the VO2 plus half cell is the negative electrode, and the manganate then is the positive electrode, the MnO4 minus. Next, the reaction taking place is a redox reaction. Explain by referring to oxidation numbers in the cell what is meant by the term redox. So if we look at the vanadium first, it goes from +4 in the, I need to do that with this, in the VO2 plus to +5 in the other one there. And then the manganese is reduced from +7 to +2. And then you need a statement explaining what redox is. So of course you're going to say something like it's when the oxidation number of one element goes up and the oxidation number of another element goes down in the same reaction. And that final bit, in the same reaction, of course, is very important. Number 2, write the equations for the reactions taking place in the two half cells and combine them to obtain the overall equation. So you're just looking back then at what you can see here, okay, and then writing those as little equations. So you can see we've got VO2 plus and H2O, because it's VO2 plus and 2H plus an electron, and then the manganate MnO4 minus plus 8H plus 5 electrons gives you Mn2 plus and 4H2O. And if you're wondering where that came from, again, we're just using the left-hand rule. So the top one is going to go to the left and the bottom one is going to go to the right, because the more negative it is, the more negative the electrode potential is, the more likely it is to be oxidized. Now to give the overall equation, we simply have to add them together. So we've got 1 electron in the vanadium equation and 5 in the manganese, so we multiply the top one by 5, and then we can cancel out the electrons and some of the waters, and that will give us eventually MnO4 minus plus 5 VO2 plus H2O gives you Mn2 plus 5 VO2 plus 2H plus. The colour change then in the VO2 plus half cell, it goes from blue to yellow. And the colour change in the manganate half cell, we've got pink/purple to colourless. The reading that we observed in the voltmeter was plus 1.51, take away the plus 1.02, which is 0.49 volts. Explain the purpose of the salt bridge and how it works. Well, it completes the circuit with no metal present, so the ions in the circuit conduct electricity, and there's 2 marks for that, so 1 for each. And the electrode potentials of half cells are measured using a hydrogen electrode. Describe a hydrogen electrode and state the conditions under which it operates. So you've got hydrogen gas, which you can say is bubbled over a platinum electrode, you could say which is covered in platinum black. And then the other condition is 25 degrees C, or you could give that in Kelvin. The hydrogen ions then are 1 mole per dm cubed, and the pressure is 100 kilopascals. So 4 marks and 2 marks for the top part. This bit, the hydrogen gas bubbled over the platinum electrode, and then 2 marks for the other. Write equations for the changes that take place at each electrode for an alkaline hydrogen oxygen fuel cell. So the hydrogen electrode, it's simply H2 plus 2OH minus gives you 2H2O and 2 electrons. And then at the oxygen electrode, it's O2 and 2H2O plus 4 electrons gives 4OH minus. Then write the overall equation for the reaction in the cell. So 2 electrons in the top, 1 in the hydrogen electrode, 4 in the oxygen electrode. So we're multiplying the top one by 2. And overall that gives us then 2H2 plus O2 gives 2H2O. And the EMF in the cell is plus 1.23 volts. State one difference between a fuel cell and a rechargeable cell. Well, the fuel cells require a constant supply of fuel. Rechargeable, you don't need to feed it any fuel, but you do need, obviously, to recharge it. So that's all the electrode potentials.